there are three transformations we'll be looking at. We'll be looking at translations, which you recall from middle school slides. We will also be looking at reflections, which are our flips, and dilations, which are being stretched or shrunk. So whenever we're looking at a transformation, we are comparing the line or curve to the parent function. And for linear, our parent function is y is equal to x. It has a slope of 1 and it starts at the origin. That would be our parent function. For the quadratic, our parent function is y is equal to x squared, has a vertex at the origin, and then it's the most basic quadratic, just being x squared. So the first type of transformation we're going to look at is a translation. And there are two types of translations. There's those that go vertically or up and down. So vertical shifts move up or down. And then there's those that go horizontally. So for a vertical shift, we can see that for a line, if it's a vertical shift up, it moves up. That would be a vertical shift up. If it's a vertical shift down, the line would move down. And we can really look at where it is crossing the y-axis. So that's a vertical shift down. Now, looking at the equation, I can also tell by the number that is after my linear term. So if I have a plus a number, like this, +4, that is when it is vertically shifted up. And it actually went up 4. This even tells you how much it's going up. If I have a minus after my linear term, that means that I'm going down. So just looking at that equation, I can see that it's a vertical shift down 2. And these actually correspond to the graphs. So this one went up 4, so it's now going through the y-axis at 4. And this one went down 2. Now it's the same thing with the quadratic. You can see that we have our parent function going through the origin, and that we have this blue function is vertically shifted up 4. We can tell that by the picture, looking at the graph, but also from the equation, if we see plus, that means it's going up, and how many is 4. If it is going down, we can tell because the vertex shifts from the origin, so it's vertically shifted down 2. But we can also tell by the equation, because just like the linear, after the quadratic term, we have a minus and then a number, and there it is, -2. So that goes with that. So those are our vertical shifts, easy to tell from the picture, also easy to tell from our equation. Then horizontal shifts. Horizontal shifts move left and right. They move horizontally. Now, with a linear function, you don't really have a horizontal shift because a horizontal shift could be considered the same thing as a vertical shift. What does that mean? If I'm looking at my parent function, which is the red one, and comparing it to this green one, I can see that it vertically shifted down 2. And that's really what I would call it. But you can see that that may also be considered a horizontal shift right 2. We tend to just go with the vertical shift because it describes it well enough. You cannot do that with the quadratic though, because with the quadratic it's definitely different looking. The horizontal shift looks different than the vertical shift. So you can see that this one is a horizontal shift, and it went left 4. And then this one, the green one, is a horizontal shift, and it went right 2. Now the difference is when I'm looking at the equation. If it is a horizontal shift, it is going to be in parentheses and then squared. And if it says a +4, that actually means it's going in the negative direction. So this +4 is actually a horizontal shift left 4. And the one that has the minus in the parentheses would actually go right or to the positive directions. Horizontal shift, right to. So these actually go opposite of the sign. Plus would shift left, and the minus would shift right. Now that's why when we look at the linear, we don't really consider it a horizontal shift because the linear is not in parentheses. So it's not in parentheses, so we would just consider it a vertical shift. So those are our translations, two of them, vertical and then horizontal, but the horizontal mainly pertains to the quadratic. Go to the back. And then we're going to look at dilations. And we have two types. We have shrinking or compressing something, and then we have stretching it. If you think back to what you did in middle school, you were either stretching a shape larger or you were compressing it smaller. And you didn't necessarily call them compressions or stretches because they were a physical shape. These are a little harder to see, to notice, because it's not a closed figure, it's not a polygon, and they go forever. In both the linear and the quadratic, our parent is in red. So this is my parent function, going through the origin, up 1 over 1. That's the y equals x. And this is my parent function, quadratic. Vertex is at the origin, that's y equals x squared. When we have a compression, that means it's being flattened out. So flatten out, how can you tell? Well, if you look at the parent, the compression is being pushed down flatter. And the same thing on the quadratic. It's being pushed from both ends, but it's being pushed down so the shape is flattening out. How can we tell from an equation if we have a compression? Well, if we have a fraction that is between 0 and 1, we don't worry about the sign here. The sign is going to be a different type of transformation. But if we have a fraction that is less than 1, that means we have a compression, or that our shape is being pushed down, or our function is being pushed down. Now the other type is a stretch. So how do you know when something is being stretched? Again, we're comparing back to our parent function. And when something is being stretched, it looks like it's being pulled up or getting narrower, more vertical. So if we look at the line, the linear one, it's like if the parent function is being pulled up and our our line is becoming more vertical. And the same thing with the quadratic. It's being pulled up on both ends and it's being made narrower. How do you know from the equation? Well, you're going to have a number in front of x that is greater than 1. It could be a fraction. It could be 5 halves. But it's greater than 1. And that's how we know we have a stretch. And then our last transformation is the reflection. And it's the easiest one to notice, at least from an equation, and also, I think, from a graph. So if we look at the left side of your paper, we have a linear, which is positive. That's not quite our parent function, but we'll just pretend that it is. And then we also have our quadratic, and it is a U shape. So this is not considered a reflection because our number in front of our linear quadratic term is positive. When it's a reflection, we have a negative in front. So that means our slope becomes negative, going downhill, and that's how we know that that's a reflection. So if we have a line that's going down, it's a reflection. And for the quadratic, if our U is upside down, that is a reflection from the picture. So from the picture, if we have a line that has a negative slope or is going down, it's a reflection. If our parabola is upside down, or a U is flipped, it's a reflection. We can tell from the equation if it has a negative. So let's take a look at some examples. So first we're going to name the transformation given the equation. And I also want you to tell me if it's linear or quadratic just for practice. So looking at this first one, it's linear. How do I know? Because it just has an x. If it would have an x squared, it would be quadratic. And then I noticed that it has a plus 5 after my linear term. Well, if I have something after the linear term, that would be considered a vertical shift, and it is telling me which way. Plus is up 5. So that is a linear, then it has a vertical shift up 5. For number 2, it is quadratic, and I know that because it has an x squared. And then it has a number in front. So if it has a number in front, that means that it is a dilation, but which type? Well, if that number is greater than 1, it is a stretch. Number 3, I see that it has a squared, x squared, so that's going to be quadratic. But then it's in parentheses, and the only transformation that I have that is in parentheses is a horizontal shift. But I have to remember that although it says plus 3, the horizontal shifts they go opposite of the sign, so this will actually go left 3. Number 4 is linear, because it just has an x to the first power. This has a number in front of the x, which is 2/3, which means it's going to be a dilation. But what type? Well, 2/3 is less than 1, so it will be a compression or a shrink, depending on which word you prefer. Number 5's got a couple things going on. First, it's a quadratic, because it has an x squared. Then I notice it has a negative out front. That would be a reflection. Then it has the number 3, so that means it's dilation, but which type? 3 is greater than 1, so it would be a stretch. All right, number 6, we have an x squared, so that makes it a quadratic. I notice that we have that minus out front, so that's a reflection. And then we have the plus 2 after the quadratic term, and it's not in parentheses, so that means it's going to be a translation, but it'll be a vertical translation up 2. So you just need to learn those, learn how to read the equation and what it means, what the numbers mean, or the negative signs when you're looking at an equation. Now we're going to do the opposite. We're going to write the equation given some information. So looking at number 1, first thing they're telling me is linear. So I'm going to write y is equal to x, because that's linear. That's the parent. Then it says shifted, vertically shifted. So that means I'm going to have something after the x. It says down 2. That would just be a minus 2. That's how I show it vertical shift. Number 2 says it is quadratic, so that's y equals x squared. That's my parent. Then it has the word reflection, so that means I need to have a negative up front. Negative. Number 3 says linear, so y equals x. Reflected, so reflection has a negative in front of its x. Vertically shifted, up 6, so plus 6. And then the fourth one says quadratic, so y equals x squared. Horizontally, horizontal, I need to erase that square. As soon as I see that word horizontal, I know that I need to put parentheses and squared. Leave a little space so I can enter which way it's shifting. It says horizontally shifted right 3. So right is the positive direction. That means I need to put a negative 3. Then it says vertically shifted down 2. So that's going to be after the quadratic term, down 2. All right, and the last thing we're going to look at is comparing the graphs and just determining what type of transformation it is. Our parent function will be solid, and our transformation will be the dash. So looking at number 1, I can see that they are both still going through the origin. So there has been no shift vertically. So it's not going to be a translation, but it is getting more vertical, the line itself. This dash line is getting more vertical, so it's being pulled up. That is called a stretch. It's a dilation, but it is the stretch. And it's linear. We'll do that just for practice. Number 2 is quadratic. How do I know? It's got that nice U shape. And I can see that the parent has its vertex at the origin, and the transformed shape is no longer at the origin. So it slid to the right. That would be a horizontal shift, right. And how many? It went 2. Third example is a quadratic. Still has that U shape. First thing I noticed between the parent and the new shape is that it moved down 2. So that's a vertical shift down 2. But it's also getting pressed out. It's being flattened. And when it's flattened, that is a compression. And then the last one, number 4, it is linear. First thing we notice is it's no longer going through the origin. So it's vertically shifted up 3, because it moved from there to there. But then it also doesn't have a positive slope anymore. It's going downhill, which means it is a reflection. All right, you got some U-do's to try on your own.